Today on the fermentation, how much alcohol? Let me count the ways. Welcome to the fermentation. This is the podcast for City Steading Brews YouTube channel. I'm Brian.
I'm Derica.
And today we're measuring alcohol. There's so much to this and so many ways to do it. And I know somebody is already saying, I don't care how much alcohol I'm making. Well, even if you don't care, it's still a good idea to know how to do this just in case, because there are times that it's very important. But first, the first thing we want to talk about is...
calculating is an estimate.
Yes. No matter what method you use to calculate the alcohol in your brew, it is an estimate. So when I see people saying, oh, I made 14.672525457% alcohol, I'm like, anything past that first digit after the decimal is really suspect. Even the first digit after the decimal is really suspect.
Curious to me because there have been quite a few people who not only stress that this is what they got, but they argue that it has to be correct because the math is correct.
Yep.
And there's a little caveat to that we'll get to in a minute. And then even when we say it doesn't matter, even commercially, there's a 2-point variance.
I forget if it's 1, 1.5, or 2. Well, what we mean by that is if a commercial winery puts 12% on the bottle, it's either they can be 11 to 13 or 10 to 14, something like that. They have a wide range of what can still be marked as 12%.
Legally.
Yeah, and that's a commercial maker.
Right.
So.
But even when we say that, we've had commenters say, no, I need it to be this 1.
I need to be 13.752. Like why? I never really got an answer to that. So I'm actually curious why, because it would be one thing. It'd be one thing if only one person ever said that, but lots of people have said that.
Yeah.
Lots of people say things like that, not that exact number. If it was that exact number, that'd be even more weird.
That would be weird. Okay, so let's talk a little bit about the math and how, even though the math technically is correct to get the 10 gajillion decimal point thing.
But it's not.
And we need to express now why it's not.
Here's the thing. As a brew ferments, more alcohol is present. Alcohol is 0.790 specific gravity. Water is 1.000 specific gravity. So as the amount of alcohol goes up, it's going to reduce the specific gravity. That's part of how you can calculate how much sugar has been used, because sugar adds density, right? So that means if you add sugar to water, it's now more dense. But then when you start mixing alcohol into it, which one's right now? And it gets so crazy. And here's the thing. It's not an X plus Y equals Z. It's a sliding scale, okay? Let me just give you the basic formula that most people use for calculating alcohol. They take the original gravity minus the final gravity and multiply that whole thing by 131.25. I'll get to why we used to use different numbers and stuff in a second. It's that 131.25 that actually should be changing depending on the percentage of the alcohol. But you can't know what to use until you know how much alcohol you have. Therefore, it's a very sort of inexact thing. So 131.25 is actually generally fairly accurate up to about 7 to 8% ABV. And it's commonly used for beers. It was used for beer for many, many years, and that was like the standard. However, there are calculators online that are going to do the more accurate way. I've done a couple of videos on this already, so I'm going to synopsize those. But the gist is it changes depending on how much the percentage of alcohol is. So it's a much more complicated formula. There is another formula, I forget what it is, I used to know it, that uses that and gives a much more accurate reading, but you're still using some standards that kind of fluctuate depending on a lot of factors. Now, we used to use 135 as our number, and I would still stand by the fact that if you calculate using 135 instead of 131.25 for anything above 8%, you're probably a little bit more accurate. But when I say a little bit more accurate, usually within 0.2 to 0.5 of 1%. So like a quarter to a half of a percent. That's the main difference between them. And we're talking only at the higher numbers, like 16, 17, 18%. You see that 0.5% change. To me, that's just not worth it. And why do I say it's not worth it? Because I could not tell you how many people told me I was stupid for using 135 when the whole world uses 131.25. Now, if they started out the conversation that way, it went south real fast. Many people asked why we do 135. So it turned into, I ended up explaining it and explaining it and explaining it. I just felt like we were fighting against a tidal wave of not understanding. And then I realized, we did a bunch of tests about something, I forget what it was. I realized it just doesn't matter. That 0.5 percentage point makes no difference whatsoever. Because if I calculated something to 13.6, I usually rounded it down to 13 anyway. So what difference did it make if it was 13.6 or 13.2? It really didn't matter. I put it as 13. So it was a little bit of going in with what everybody else is doing, because 131.25 is the standard. Everybody uses it. A lot of online calculators use that. And only one uses 135, and they credit us with it, by the way, just saying. So I just said, it's just not worth having to explain all the time, where the 131.25 everybody was familiar with. So that's a little bit about the math. Basically, even the formula of 131.25 is still an approximation, and there is a very specific ABV level. I forget where it is, like 5.7 or 5.4, I think, where it is accurate. Anything other than that, it's slightly inaccurate. But it just doesn't matter because it's close enough.
So another variable to throw a wrench into the works is the devices you're using to take these measurements in the first place. Your accuracy is going to be dependent on their accuracy. And if you look at a hydrometer, for example, those little marks
They're
in
like,
between.
What, a 16th of an inch apart?
Right. So how many decimal points can you differentiate between those little tiny marks on your hydrometer? You probably can't.
Well, 2. You can go 2 points.
Sure.
Which means you can't ever be more accurate than those 2 points.
Right. Just like, say you're measuring with a tape measure, right? You're not going to get a gajillion decimal points off of that tape measure. You're only going to get...
Usually a 64th of an inch is the smallest they go.
Yeah.
But also with a hydrometer, you have more things because you're usually doing it through glass or plastic. So that could obfuscate the view a little bit.
And
then
you're dealing with liquids. So there's the meniscus.
Right. You're supposed to read from the meniscus. And if you can't get an exact view or if there's any bubbles in there, the accuracy starts to fade. And that's all we're trying to say. I'm not saying that you can't do it, but it starts to become a little bit more difficult to be truly accurate with a hydrometer. Now, you could be argued you use a refractometer, it's more accurate. Well, not really. They're about the same. And then there's higher end gear that may be slightly more accurate. But again, does that extra 0.5 of a point really matter? Like, to me, if I read something as 1.004 and then like I just got a tilt and it reads 1.0042, do I really care about that last 2? It doesn't make a difference. It means almost nothing.
And to me, the people that have the availability to the higher end gear and precision are commercial makers. And if they have a leniency of 2%.
Well, they still spot check is what it is. They can't check every single bottle. So they have to spot check every so often.
Yeah.
But their leniency for printing, because think about it, they have to make labels.
Sure.
What if every bottle had to be labeled within 1/10 of a point? Imagine how much more wine would cost just because of the labels.
Yeah.
They'd have to make a new label for every bottle or every batch or whatever.
But I guess my mindset is the matter, the point, the importance is that non-important for commercial brewers, then why do we have to sweat about it so much?
And it's funny because we get both sides. I get people that will argue with me up and down that you shouldn't even be taking specific gravity readings, that you don't need to. It's not important. I can tell by taste. I can look at it, know what the ABV is, and all kinds of stuff that people have said. Now, I'm not picking on anybody in particular. I'm using hyperbole on purpose.
Sure.
All the way to people that literally want to give me like 15 digits after the decimal point for the ABV calculation. And they will insist that that's accurate. It's really amazing the wide
discrepancy.
Breadth of people discrepancy is a good word too, breadth of people that do this hobby
Yeah.
and their motivations. Like for me, I'm a math guy. I like numbers to be close, but once I realize that a little bit doesn't matter, I don't worry and I start to round things off in my head. It makes math easier. It makes my process simpler. And at the end of the day, I don't care if it was really 14.1267 and I put it as 13.5. Because does that mean I'm going to go, oh, nope, can't drink that one. Not 14.12675. Only 13.5, can't drink that. You know, I'm not going to do that. And if I handed that to someone and they said, oh, I only drink things that are over 14% and I marked it as 13.5, I take the bottle back and don't ever offer them anything again because that's just stupid. And I'm being a little bit facetious here, but it's kind of true. We see these kind of things come through and I just wonder where some of it comes from because we are not elitist brewers in any stretch of the imagination.
Nope.
We, in fact, try to look at some of the things that we see promoted and say, where did this come from? Is it true? And do you really have to do it? And a lot of time we're finding out that some of it's just people do it because that's what they've been told they have to do. So we try to dispel some of that stuff. We're the brewing mythbusters. Ooh, I like that one. But anyway, back to this.
So those people that say, I don't care what my ABV is, well, we're kind of with you. And hopefully what we've already talked about shows that that's not our priority, our objective, our main objective for reading hydrometer and taking gravity readings in the first place. So why, Brian, would you want to have these gravity readings?
The first reason why you want to take a gravity reading, it's not even on the notes. I'm making this up. We're going off script here. What? The first reason is so you don't screw up. I mean, I can't tell you. This is a joke that I use all the time now, but it has happened. I have gotten this comment. I accidentally put 6 pounds of honey into 1 gallon. What do I do now? And my first thought is, how did you accidentally put half a gallon of honey into a 1 gallon container?
Yeah.
At some point, you had to realize that was more than a couple of pounds.
Like, did you start pouring and just walked away?
That's the only thing that makes sense. But it's happened more than once, okay? More than one person has said that. So taking a gravity reading, taking the first measurement that you need for calculating your alcohol is actually a very helpful thing because it tells you, oh, crap, I screwed up. This is way too high. My yeast aren't going to be able to do this. So just the oops factor alone makes it worthwhile. And I know people that I make the same recipe all the time and blah, blah, blah. Yeah. And you know what? Half the time they tell me that they don't even measure the honey either. So sure you do. Sure you're making the exact same thing. Unless your jars, like you're using a whole jar or something, that makes sense. But if you don't measure anything, you can't tell me you're making the same thing every time. I just don't believe you anymore. But that's not what we're talking about here. The next is yeast tolerance. And that goes along with the oops factor. Like if you're using a 15% tolerant yeast and you put enough honey to make 18%, you can be pretty sure that that yeast isn't going to finish that out dry. And you can be reasonably assured that it's probably going to stall before it even gets to 15% because that's just the way it works. And it's more important when you start using lower yeasts like USO4, or not USO. It's not USO4. It's just SO4. It's USO5 and SO4. And I always add a U on there. But SO4 supposedly is like a 10 to 11% tolerance, even though it really goes to like 13 or 14. But it's supposed to be like a 10 or 11% tolerance. So it's really easy to overshoot that one because 11% is below my target of 1.100, which gives you about 13.125% alcohol. See how that works? But anyway, so it's really easy to overshoot that one. And depending on the yeast you're using, knowing that one crucial piece of information can actually save you a lot of trouble later in dilution and stuff like that. I feel like I've been talking a lot. You need to take the next one.
All right. So the next one is, are you done? And so you're going to take your first gravity, your original gravity, as it were, when you first make your brew. And then you're going to take one, probably two, preferably two, towards the end of fermentation to determine, is your brew done? And the way you do that is you take a gravity reading, you check that number based on your recipe, based on the yeast that you used to see, are you in the target range of your alcohol percentage tolerance for your yeast?
We actually did a video on that too.
And then you wait another week and you take another reading and you compare those two readings, and if they are the same, then that means fermentation is done. Having all the other information is going to tell you if the brew has completed or if it has stalled.
Right.
We've done other videos on that as well.
Notice what she said, though. If it doesn't move, it means fermentation is done. She didn't say it's finished.
Yep.
It could be stalled. It could be done. That's a whole other thing. We actually did a video on that, just that topic.
Yep, just said that.
Yeah, I know. I'm reaffirming that because a lot of people ask. I wanted it to be said. And that's a really important thing to understand, because it's one thing to overshoot in the beginning, but say you missed that somehow. Now at the end, am I done? Is this in the right range? Really important to have those readings. So we're stressing gravity readings because that's the easiest way to calculate your alcohol. And we'll get to more on that in just a little bit. I know a lot of you are going, you told me you're going to figure out how to calculate alcohol. And we are. We're telling you all the different ways not to do it and how to get there eventually.
So the last reason why you want to know what your alcohol percentage is for preservation.
Yeah. The higher the ABV, the longer, in theory, that brew can sit at room temperature for preservation purposes. And this is why, like, if you've ever heard of IPA, it's a very popular thing. It's called India Pale Ale. The reason why there's more hops in that is because hops are a preservative. So initially, beer couldn't make it around, I think it was around the southern tip of Africa to get to India, or from India to England. One of the two. It was that trip. They couldn't make it because it would spoil. So they started adding more hops to it, and it was able to make the trip. And thus we have India Pale Ale. But in the brewing world for meads and wines, we don't have low ABVs like that, because that was the real problem. Beer spoils more easily because it's a lower ABV and a million other factors, but that's why it spoils easier. Whereas a wine or a mead at 12, 13, 14% is not going to spoil nearly as quickly. So it's important to know that you're into that range rather than at 8%, where it could spoil a little bit more quickly. That said, I want to talk about that just briefly. We have not had much issue with preservation. We really haven't. We have said it in videos that, oh, this one might not make a year because it's a cider or whatever, so we're not going to keep them for a year. And we have them.
We have them, and we drank them, and they're just fine.
Now, that doesn't mean all the time. It's kind of the general rule is the higher the ABV, the easier it'll keep. Like, for instance, a beer versus a whiskey in the bottle at room temperature, the whiskey's going to last longer than the beer. Like, you come back in 100 years, the whiskey's going to be exactly the same. The beer is probably not going to be good anymore.
Unless it's in the presence of Brian, then the whiskey might be gone.
That's true. But I mean, like, all things being equal, nobody touched it, nobody drank it. Yeah, that's true. The whiskey would never last a year. 100 years. 100 years? Won't last a day. Maybe a week. Okay. So preservation is really important. And like I said, general rule of thumb, once you pass 9 or 10% preservation on the shelf at room temperatures, pretty much you're fine. Below it, as long as you bottle it well and everything goes sanitized, you're probably fine. You see the difference there? That's the easiest way I can say it.
All right, so that has been our collection of whys, and now we're going to our collection of ways.
Yeah, she wrote the notes out really cute. I just noticed that. I didn't see this the other day when we were going over it. The ways. My preferred way to do all this is with a hydrometer and a calculator. That's really all you need. And you need to have an original gravity when you first start up. You need to have a final gravity when it's done. And it needs to be when it stops moving. Okay, we said take 2 readings, 1 a week apart, but it really needs to be when it stops moving. If that changes, keep waiting a week and then checking again.
The last 2 that are the same. So if you still see movement, keep waiting a week and doing the process over again. Yep.
And then you just subtract the second number from the first, or the ending gravity from the beginning gravity, multiply that by 131.25, and you get an approximate ABV. Now, if you sweeten or add anything to it at that point, it doesn't add or subtract from the ABV in that way. I've had a lot of people, and I'll get to the caveat in just a second. I've had a lot of people say, oh, but I back sweetened it to 1.030. Does that mean it has less alcohol now? Yes, but not for the reason that they think. They think it's because now the gravity is different that changes the formula. That does not change the amount of alcohol.
No, the gravity reading at that point is just the density based on the additional sugars, has nothing to do with the alcohol. The only reason why the alcohol would change is because you've added something physically to that. So you've diluted your brew. Yeah.
Yep. And so like say you added a pound of honey to 1 gallon of mead. Now, that would be about 1/12 of it being diluted. So if you had 12% ABV, it's going to drop it by about 1% by putting in a whole pound of honey into a gallon. Rough numbers. I just did that off the top of my head. It's about there. By the way, if you didn't know, a pound of honey is about 11 fluid ounces, which makes 3 pounds of honey just about a quart. It's 33 ounces, just about 33 ounces. I love stuff like that because that way you can calculate your recipes easier and knowing these little general rules of thumb. Now that is in general. Every honey is just a little bit different because it is a natural product. So that's something to remember, but kind of gives you a good rule of thumb. I know a lot of people like to do ABV calculation by how many pounds of honey they put in and things like that. Like this much honey gives this much ABV. That's a nice general rule of thumb, all things being equal. That means if it all ferments out to exactly the same point every single time, that rule works. But if it goes below or above, that doesn't work as well. That's why readings are actually the best way. We like to use a triple scale hydrometer, and that's an interesting thing too, because on the triple scale hydrometer, I'm going to say something that I'm probably going to regret. You can use a hydrometer and never have to worry about specific gravity, and you can still calculate your ABV just fine.
What did you just say?
That's right. I said it. But you're still taking 2 readings.
Yep.
But you're taking potential alcohol readings. And I've started doing this in the videos. We show it now because this is actually really simple and really easy. I learned specific gravity, so that's the way I do it. But the potential alcohol works as well. But it's confusing when you first do it. I have had many, 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 many people tell me, what went wrong? I just checked my mead and it's done and it's reading 0% alcohol. I have actually had worse, people saying that they dumped it out because there was no alcohol in it.
They're forgetting one of the most critical words in that reading, and that it's a potential alcohol reading. So that's why at the beginning, when you have all those fermentable sugars available, it's telling you potentially this could go to this much ABV.
Now, this makes a couple of assumptions. 1, that there is sugars to ferment, and 2, that it goes to 1.000. Just like using the volume to calculate the ABV before, like saying 1 pound equals this many percent, this assumes the same standard every time. If it goes a little higher or a little lower, that's going to change. I've actually had people suggest that anything below 1.000 should not be counted. I disagree with that. I don't think that's accurate because, as I said earlier, it's a sliding scale. The more ethanol, the lower that number goes. So if you start to not count those, I think you're making an inaccurate thing even more inaccurate. So just use them. It's okay. There's only a few points usually.
Yeah. And I think part of the reason for that is people get confused. 1.000 is the gravity of water.
Right.
Generally.
Doesn't mean dry.
Where
Actually, wait. It doesn't mean no sugars.
Right. Where the density of alcohol is actually below the density of water. So
0.790.
Right. So that's how your gravity reading could go below 1.000.
Because you have a mix of those two things.
Yep.
But the triple scale is great because if you take your potential alcohol at the beginning and your potential alcohol at the end and subtract them, you just found out your ABV. That actually makes the adjustment for a higher or lower gravity. So it's the same accuracy as using specific gravity because you're doing the same thing. The cool part is we do this a lot on the channel now is if I take a reading, like say I'm at 1.100, I'll just show turning that in my hand on the triple scale and it goes right over and it shows 13%. That to me, that's a tool that just works. And this is why I sing the praises of the hydrometer all the time. It's very simple. It's been around for a long time. Even the super cheapy ones are pretty darn accurate within a point or two. Most times. I mean, you're going to have the exceptions. But, you know, buy 3 of them. You're going to drop one. You're going to lose one. And then you have one to use.
Yeah. And if you're
that's the way I say it.
super extra accident prone, then you can get the
The Herculometer. We tested that and found that it was just as accurate as the regular hydrometers.
Yep. And nearly indestructible.
Oh, yeah. If you want to see us destroy one, we did drop tests and everything. I smashed it, I think, with a brick or a hammer at the end. We'll link that video. It's funny that video didn't do as well as I thought it would. I thought that
yeah,
one would
we're like,
off,
we're breaking stuff. Why are people watching this?
And I mean, it was slow-mo and smashing and everything. It was awesome. That was a whole day project to do, too.
It was a fun project.
Yeah, I was up on a ladder on our roof dropping hydrometers. I mean, by the way, I was trying to hit like I think a 4-inch target from 12 or 14 feet in the air.
Yep.
That was impressive, actually.
It was.
That we were able to do it. But the Herculometer was great. I don't know why. I just never caught on to using it. It just never stuck with me. I like my glass hydrometers. That's what I like. That's what I go for. But the Herculometer worked great. A lot of people loved it. We tested its accuracy. It was just as good.
But there's a new device further down on the list.
Yeah, we'll get to it. Another way to check SG is a refractometer. Now, these come with some caveats. Okay, a refractometer on the surface sounds perfect. Sounds great because you just need a drop or two and you get a reading. There's no waste. There's no muss. There's no fuss.
But
they do need calibration, though, which is really simple to do. You just do it with fresh water. But once there is alcohol present, it's going to give you some wacky numbers. And you need to find a calculator online. Brewer's Friend is an example that can make the adjustment for you. We did a video on CSB that we tested side by side a hydrometer versus a refractometer with all the tests and everything and found that, yeah, they're virtually the same, essentially the same thing. The difference is a refractometer may or may not be thrown off by colored things and stuff like that. Anything that has a light diffraction index to it could potentially cause some inaccuracies. Is it a big deal? Probably not. But to me, I just use a hydrometer. It's just simpler. But they do essentially the same thing. So you can still take a beginning gravity and an ending gravity and find out your ABV. Now, some people like to use a refractometer at the beginning when it's still accurate, like for the starting gravity, and then they switch to a hydrometer later on. And that's fine too. You can mix and match. I would prefer to use the same instrument for starting and finishing gravity, though, just for consistency's sake. Also, because I like to do that, I like to use the same instrument all the time. That way, every batch to batch to batch to batch, I know it's consistent relative to each other. I hope that makes sense. I just like things to be consistent, not necessarily accurate. Little note about that. Hydrometers are calibrated usually to 60 degrees. Well, ours is 60 degrees. Some of them are higher. Some of them are lower. And we take our readings almost all the time at about 74 degrees, which you could say, oh, you should be making the adjustment. I say, no, I don't need to because it's off by X amount. But every single reading we take is off by X amount. The only time I make that calibration adjustment is if we're using something that's really cold or really warm, something different than 74. In other words, I just mentally use 74 as my personal calibration because it's off by the same amount when I start, it's off by the same amount when I finish. Therefore, relatively speaking, the number of gravity points that are burned are still the same. And I'm still going to end up with the same ABV calculation. So it really doesn't even matter as long as you always do it that way.
Right. We brew in a climate-controlled environment.
Yep.
If you brew, say, in a basement and you don't climate control your basement, so it gets really, really, really cold some days and then not so much other days, then you're going to have that variable. And so you'll probably want to do the adjustment when you take your readings.
Exactly. And now that brings us to my latest toy, the tilt. I know. I said for years, don't bother. And, to a point, I don't think it's necessary. But it's pretty friggin' cool, I gotta say. I got it, and it was the easiest thing in the world to use. I just dropped it in some water to test it, and it started working immediately. Connected to my phone super fast. Works really great. I don't know its accuracy yet because there was one where we just used it in a brew. There was like a 4-point difference between what the tilt told me and what a hydrometer told me. Now, again, relatively speaking, do I care? No, because if the tilt's 4 off from my hydrometer, it's always going to be 4 off from my hydrometer. So starting gravity, ending gravity, calculate my ABV, comes out the same. Does not matter. And what I mean by that is if you start at 1.100 versus 1 point, let's use easier numbers. Let's do it this way. 1.200 versus 1.100. Okay. If I start at 1.200 and end at 1.100, I used 100 points of gravity. Times 131.25 gives me 13.1%. If I start at 1.100 and end at 1.000, I used 100 points of gravity. Multiply that by 131.25 and I get 13.125%. It doesn't matter. So that's where the actual accuracy of the unit doesn't actually matter relative to water. It matters relative to itself. And that's, to me, as a home brewer with things not needing to be super accurate, that's close enough for me. I'm good with that.
And that's why he prioritizes consistency over accuracy.
Because then relative to itself, it's always accurate.
Yep.
Unless something changes on the thing. Like, if suddenly the ball bearings come loose or something, that's a whole different story.
You got a problem.
just use the backup one that you have it on a shelf somewhere.
All right. Now there are some questionable items here at the end of our list that we're going to review ever so slightly. And Brian will try to hide the disdain in his voice.
All right.
First up is the vinometer.
This is the only one that's even sort of useful. Because the problem is they're usually very small. And they're small because the difference is very, very small to be able to measure it. And they can be within a few percentage points is really the most accurate you can be, which if you think about it, every part of the system is pretty much within a few percentage points. So they're sort of okay. Like if you totally forgot, please don't forget to take an initial gravity reading, or you're just getting started and your buddy had a vinometer, but he didn't have a hydrometer and that's all you got. For your first brew, yeah, I'll let it slide and, that kind of thing. But just know that a vinometer is not going to be very accurate. And in the long term, make the investment in a hydrometer. They don't cost much more. But if you can skip the vinometer and get a hydrometer, do that. It's a much better way to go. But that's the one that could sort of be okay sometimes to use. I don't like them, though.
Now, the vinometer, is that still measuring fermentable sugars, or is it only...
I don't know how it works. I'll be honest with you. It's kind of like a little tube with a very, very thin portion of glass, and somehow the thickness of it or something, it sits and I don't really know how they measure it.
All right.
I don't know. That's how much care I put into it. It didn't seem all that accurate to me, so it sits in a drawer and I don't use it anymore.
Well, you probably understand better the answer to that question for the second device, and that's the alcohol meter.
Okay. These do not work for fermented products. Period. End of statement. You would have to fortify so much to make an alcohol meter be able to read it. And even then it could throw it off, because alcohol meters are made for distilling. They are made for spirits that don't have extra sugars, don't have colors, don't have anything added to them to be able to check the alcohol percentage. So with a fermented beverage, first, it's too low. Usually you have to be 30% or higher before they're even remotely close to accurate, even though many of them read much lower. They're wrong. They lie. Trust me, I have one. I've tried 2 of them. They both sucked. They were both wrong. But an alcohol meter reads the spirits. So when you have a fermented beverage, it's too low, first of all. And if there's a color difference, which doesn't matter so much for those, it can affect it. But it's mostly if there's any sugars present at all, because distilled spirits do not have sugars in them. Well, such a minute amount that it doesn't matter. But a lot of fermented beverages, sweet ones especially, have quite a bit. And that's going to throw off that alcohol meter. I have literally had 8 and 9% stuff read 30%, 40%, 50%, 60%. And there's just no way. There's no way I made a mead with 60% ABV out of fermentation. It just doesn't happen.
Then there's a combo that we talked about a little bit, but we actually did a test on that because we thought, oh, this is a super cool idea. And then it didn't work. And that is the refractometer hydrometer combo.
There is a way to do it where you take readings from both and there's some calculations to do. We did a video on it. We can link it. And it works in certain conditions. The problem is you don't know if you're not in those conditions until you're not in those conditions. And that gave weird numbers too.
Yep.
I don't trust it, but for a dry, clear brew, it was roughly accurate. But that's the caveat. Dry, clear brew. And even then, how do you know if it's accurate? Well, I checked it against readings from a hydrometer. So what do I need that for?
Yeah.
Now, if you don't have, well, how would you not have a hydrometer and a refractometer?
Because you're
using them to do it.
Yeah.
So I don't know.
Just use the hydrometer.
Just use the hydrometer. It's so much easier. I mean, that system, it's a neat trick. That's about it. And, tricks are not always reliable.
Yeah.
That's my story, and I'm sticking to
We were
it.
excited about the combination in theory, but in practice.
Yeah. We get asked all the time. So I didn't take an initial gravity reading for whatever reason. I don't judge all the time. But I do have a final gravity reading. How do I know how much alcohol I made? Well, you can't know for sure. You can't even know within a reasonable amount unless you have very accurate measurements of all the stuff that you put into the fermentation. Now, if you know that you used 96 ounces of water and you used 3 pounds of honey, yeah, we can probably help you calculate that, and you'll be within a point, maybe 2 points of your ABV. And that's cool. That's really all you can expect anyway. But if you varied even by a few ounces of water or a few ounces of honey, that changes it. It just does. So that's why I say very accurate measurements of your recipe can help. But ultimately, just take a reading at the beginning, take a reading at the end. And if you're just starting out and you don't have any of this stuff yet, well, make your first one using a recipe that you know and measure as well as you can. And after that, if you get the bug, go ahead and buy a hydrometer. They're really not that expensive. And I've been using the same one now for almost 2 years.
Don't you jinx that. Don't you jinx
it. It can't hear me. It's in a different room right now. If you're just careful with it, they don't break that easily. But don't drop it. Don't drop it. Just don't. Like I say, buy 3 of them when you get them. We call them hydrometers for a reason.
Yep. Now, beyond sending samples to a lab or
that would be the most accurate way.
Some other
it's about $35 from what I understand.
Equipment that pretty much covers the ways to calculate your ABV and take readings.
I'm sure there's a lot more, and some of them are like a benchmark kind of thing or whatever. But still, at the end of the day, the best way is the hydrometer. Starting gravity, ending gravity, multiplied by 131.25 puts you in the ballpark, gets you close enough for anything a home brewer would ever need to do. I think that's the end of this podcast. As always, guys, thanks so much for listening, and have a great day.
Bye-bye.